we were dealing with ionic bonds or electrovalent bonds. Now we'll be moving to covalent bonds. Covalent bond is made by the sharing of electrons. You consider two hydrogen atoms. Hydrogen has got one electron, another hydrogen has got one electron. So they share, and each hydrogen needs two electrons. Each hydrogen needs two electrons to complete the duplet. Helium has got only two electrons. For helium, the inert gas, it is stable not due to octet but due to its duplet. Means its shell is complete, that's all. So they share these two electrons. We say by sharing, the force of attraction between them formed is called a covalent bond. And that covalent bond is that covalent bond is made by the sharing of electron. It gives, bond means attraction. So the force of attraction between these two hydrogens are, that is called covalent bonding. Covalent bonding is formed between the atoms of same electronegativity. If one is high electronegative, one is very less electronegative or electropositive, the bond formed between electronegative and electropositive, that is an ionic bond. But here, same electronegativity or same type. So hydrogen and hydrogen, the hydrogen electropositive. So both are electropositive. Similar ones between similar ones between same ones, the bond formed is covalent bond. So that there is only sharing taking place. Now you consider chlorine. Again, between both the chlorines are same. And if between two atoms, if their electronegativity is there is not much difference between their electronegativities, then also covalent bond. For example, CCl4. CCl4 means carbon tetrachloride. Carbon tetrachloride. So here, around carbon, the valence electrons, I have shown only the valence electrons, inner shell electrons I haven't shown, because valence shell electrons are taking part in bond formation. So we write only the valence bond. What is the atomic number of carbon? That is 6. Electron configuration 2, 4. These first two electrons I haven't shown. The 4 electrons that they are in the outermost shell or the valence shell. Valence shell electrons will be participating in bond formation. So here I have shown only the valence electrons. Similarly, chlorine's valence electrons, that is 1, 2, 3, 4, 5, 6, 7. 7 valence electrons. Here again one more chlorine, 1, 2, 3, 4, 5, 6, 7. Another chlorine, 1, 2, 3, 4, 5, 6, 7. Another chlorine, 1, 2, 3, 4, 5, 6, 7. These things you learned in class 10th also, and we made covalent bonds between them. See, between these two electrons, one bond, one bond, one bond, one bond. So chlorine got 8 electrons, carbon also has now 8 electrons. All are happy, all are satisfied with octet, 8 electrons in the outermost shell. So the bond formed is a covalent bond. Covalent bond, covalent bond, covalent bond, covalent bond. Here we were showing only the valence electrons. Showing of valence electrons of each and every atom, that is called Lewis dot structure for the atoms. Let's see the Lewis dot structure for the atoms. Lewis dot structure. For hydrogen, we show 1. Last shell, 1 electron. Helium, 2. Lithium, last shell, that is 1 electron. Last shell, only 1 electron. Beryllium, last shell, 2 electrons. Boron, 3. Carbon, 4. Nitrogen, 5. Oxygen, 6. Fluorine, 7. Like that. We show neon, 8. For showing of only the outermost shell electron, that is called Lewis dot structures. Lewis dot structures. Now we used only the outermost electrons. In the case of that CCl4, when we made, we showed only the outermost electrons. So we showed only the outermost electrons of carbon. We showed only the outermost electrons of chlorine. So showing outermost electrons, that is called Lewis dot structure. In the case of CCl4, we drew C, Cl, 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 Cl. 4 bonds, 4 covalent bonds. These are single bonds. But last year in organic chemistry, you learned C double bond C, H, 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 H. If 2 pairs of electrons are shared, this is 1 pair, this is 1 pair, we say it is a double bond. But here single bond, single bond, single bond, single bond. Here it is double bond. In the case of C triple bond C, H, H, this is ethyne. Last year you learned in organic chemistry, ethyne or acetylene. There is a triple bond, means 1 bond, 2 electrons, next bond, 2 electrons, next bond, 2 electrons. So this is a triple bond. Here you see only single bonds. Here you see a double bond also. Here you see a triple bond. N, triple bond N. There are 3 bonds between nitrogen. O, double bond O. There are 2 bonds between oxygen atoms to form O2 molecules. So single bond, double bond, triple bond. Double bond means double attraction. Triple bond means again more attraction. Bond means attraction. Next, we will be seeing how to write the Lewis dot structures for molecules. Heading Lewis dot structures for molecules. For that, for example, CO3 2 minus carbonate radical. Carbonate. We are going to write the Lewis dot structure for this. Carbon, oxygen, oxygen, oxygen. 3 oxygens are there. Now that part is over. 2 minus means you have to, means 2 electrons are present in this. Okay. So plus 2 electrons we write. Plus 2 electrons we write. So carbon, 4 electrons in the outermost shell. So valence shell mein how many electrons are there, that you have to write here. That is 4 electrons for carbon. The valence shell electrons in the case of oxygen is 6. So we'll be writing 6 here, again 6, again 6, plus 2 electrons. 2 minus means it has got extra 2 electrons. So those 2 electrons we are writing. These all are electrons only. You add all these things and tell me what is the total number of electrons.
24.
24.
24.
These 24
24.
electrons we have to give to, we have to distribute to them. 1 minute. Let me do a little bit of work. Okay, these 24 electrons we have to distribute to all. To make the species means this thing, carbonate, CO3, 2 minus. You select the least electronegative element and that should be at the center. Least electronegative element should be at the center and other atoms should be standing around it. The step is given, think intelligently and make, because there is some drawback. It cannot give the shape of the molecule. This Lewis dot structure cannot give the shape of the molecule. So they are using the term think intelligently and make the structure. So I am telling you that least electronegative element, which is the least electronegative element in this carbon or oxygen?
Carbon.
Carbon. So that should be kept at the center and other three oxygens should be kept in such a way that there is minimum repulsion, means they are standing far apart from each other. So ek yahan lagaya, yahan, right? So around this carbon, I made this oxygen far away from each other so that there is the minimum repulsion and maximum stability. Minimum repulsion means maximum stability. Anyway, a species is formed, that means between them bonds are formed. Something is formed out of this, means a bonding is there, bonding between them. So minimum one bond should be there. One bond means 2 electrons. Total how many electrons you calculated?
24.
24.
24.
24. So 24 में से 2, 4, 6 used up. 2, 4, 6 used up. Now, the rest electrons you have to give to the most electronegative element. Electronegative elements, they want electron, they like to take electron. ऐसे वाला रोने वालों को पहले satisfy करते हैं. So we are going to oxygen. So 2, 4, 6 already over. 2, 4, 6, 8, 10, 12, 12. So that oxygen is happy. Now this oxygen. So 2, 4, 6, 8, 10, 12, 14, 14, 16, 18. This one is happy. 18 electrons हो गया. 24 है. So 18, 20, 22, 24. That oxygen is also happy. All the electrons are over. All the electrons are over. This oxygen is happy, this one is happy, this one is also satisfied, but carbon, bichara, carbon ke paas 8 electrons nahi aaya. See, 2, 4, 6, 6 electrons here. So what you have to do, either from this oxygen or from here, take pull karna, खींचना एक electron को यहाँ bond के format में. 2 electrons means 1 bond. एक bond के format में डालना. So carbon is also happy now. This oxygen, around this oxygen, 2, 4, 6, 8 electrons over. So this way you have to write the Lewis dot structure. If you pull from here, you get this double bond between carbon, this oxygen. You can pull from here also, from here instead of pulling here. So you'll be getting another structure called a resonance structure. Or instead of that, you can pull from here. That is called another resonance structure. There are 3 resonance structures. We call these 3 resonance structures as canonical forms. So I'm going to write the canonical forms of these. Three structures. Two minus. ये 2 minus कैसे है? The CO3 2 minus. Okay, those 2 minus. Or you learn in this way. Oxygen का around 2 bonds होना चाहिए. We are not showing those electrons. Oxygen का around 2 bonds. ज़्यादा है तो plus, कम है तो minus. ज़्यादा है तो plus, कम है तो minus. Oxygen के around 2 bonds होना चाहिए. ज़्यादा है तो plus, कम है तो minus. Nitrogen के around 3 bonds होना चाहिए. ज़्यादा है तो plus, कम है तो minus. कार्बन के अराउंड सिमिलरली कार्बन के अराउंड 4 होना चाहिए. ज्यादा है तो प्लस, कम है तो माइनस. एनीवे कार्बन को ज्यादा, that is 4 के above 5, that is not possible as you learned last year tetravalency. So ज्यादा मतलब उधर steric hindrance धक्का मुक्की हो जाते हैं. So that is very unstable species. So that species is not very much stable. So it is called C, around the C 5 bonds means that is very unstable situation. We call it as a transition state. This transition state is very unstable. It immediately changes into the products. Okay, so this is one structure. Or instead of that, you can give here 2 minus another resonance structure C, like this, like this, like this, again 2 minus. So canonical form, canonical form, canonical form. So which is the actual structure? 1, 2, 3. 1, 2, 3. For that, we are telling that 1 भी नहीं है, 2 भी नहीं है, 3 भी नहीं है, somewhere in between. That structure is called a resonance hybrid, which cannot be shown on a piece of paper or on this board. Still, we are showing in this way. That is, see, एक bond यहाँ, here, here, and this is like this. Partial bond we are showing, partial bond we are showing, and 2 minus. We are showing like this. This is the resonance hybrid. So we said this is the actual structure which we cannot represent on a piece of paper. Its structure is, this structure is the most stable, means least energy. Its energy is greater than its energy. Its energy is greater than its energy. Its energy is greater than its energy. So the energy difference between a canonical form and the resonance hybrid is called resonance energy. It is called resonance energy. Energy difference between a canonical form, the lowest energy canonical form, that is the most stable state among them. Lowest energy means most stable state. So the difference between the energy difference between the lowest energy canonical form and the resonance hybrid, that energy difference is called resonance energy. NO2 minus. Next example, NO2 minus. Nitrogen, 5 electrons in the valence shell. Oxygen, 5 electrons. One more oxygen, 6 electron. One more oxygen, 6 electron. And one minus means one electron is present. Extra one electron is present. So that one electron also we are taking. So total how much? 18 electrons. 18 electrons. These 18 electrons we are to distribute to all these 3 atoms, that is nitrogen, oxygen, oxygen. Which is the which is the least electronegative element, that is nitrogen, that we have to keep at the center, and one oxygen here. This oxygen are to be kept far apart. They will repel each other. Same people don't like each other, so they stand far apart. They always fight with each other, so they stand far apart. So anyway, one species is formed, so minimum one bond should be there. So I am putting one bond here, one bond here. One bond means 2 electrons. So 2 electrons, 2 electrons over. 2 electrons, 2 electrons over. Altogether 18 electrons in our hands. So 2 plus 2, 4 gone. Now you should satisfy the crying one, the most electronegative one, that is that oxygen and this oxygen. So 2, 4, 6, 8, 10, 10, 10, 12, 14, 16, 16, 16, 18. So that oxygen is happy with 8 electrons. This oxygen is happy with 8 electrons. but nitrogen, around nitrogen only 6 electrons are there. So what to do? Either you pull 2 from that side or you pull 2 from this side. So I am pulling from that side. Now nitrogen is also happy. I told you oxygen with 2 bonds, no charge. Nitrogen with 3 bonds, no charge. ज़्यादा है तो plus, कम है तो minus. Oxygen with 1 bond, 2 bonds, no charge. Come hai to minus. So this will be having a minus sign. That is this minus sign. That is this minus sign. So you can show the structure like this. O. This is the structure. Lewis dot structure. Lewis dot structure. Lewis dot structure for this thing. This minus is the minus charge for the entire species also. Now this is this is looking like linear, but this is not the actual structure. The shape of this NO2 minus actual shape is like this, but Lewis could not explain the actual shape like this. When the shape Lewis could not explain, so that is a drawback of Lewis dot structure. You can write like this only because what is Lewis dot structure? You can show this thing only. Actual bend structure is not given by Lewis. What is the shape of this molecule? Shape of the molecules were not given by Lewis. So that is a drawback of Lewis structure. Next, write the Lewis structure for NH4 plus. Write the Lewis dot structure for NH4 plus. Plus means 1 electron is less. Plus means 1 electron is less. So nitrogen outermost shell 5 electrons. Hydrogen 1, 1, 1, 1. So 4 hydrogens over. Plus means 1 electron gone. So minus 1. So altogether 8 electrons. 8 electrons. Which is the least electronegative? Okay, here hydrogen is very small. Yaad karna, small atom cannot be the central atom, whatever may be the reason. Small atom cannot be the central atom. Why it cannot be the central atom? It cannot hold big atoms around it. So hydrogen cannot be the central atom. Nitrogen, then what? Nitrogen can be the central atom. Center should be the bigger atom, and hydrogen. All right. Minimum 1 bond is formed between them. So 2, 4, 6, 8. All 8 electrons are over. Nitrogen with the 3 bonds, neutral, no charge. Zyada hai to plus. That's all. Kam hai to minus. So this is the structure for NH4 plus. This is the Lewis dot structure for NH4 plus. You can write it like this also. NH. Yeah, N ka plus you can write for the entire species. This can also be done. This plus means this is a sum total of all positive and negative charges totally we write on the top. That positive means that is a sum total. This is neutral. Here only plus charge on this nitrogen. So that plus charge we are writing there. Next, O3. Write the Lewis dot structure for O3. O3, O6 plus 6 plus 6, that is 18. 18 electrons are to be given. So minimum 1 bond, minimum 1, 2, 4, 6, 8, 10, 12, 14, 16, 18. So I am pulling a pair of electrons to make everybody happy. Oxygen with 2 bonds, no charge. Oxygen with 3 bonds, 1, 2, 3. Charge is positive, ज़्यादा है तो positive. Oxygen with 1, oxygen का 2 है neutral, कम है तो negative. So this is the structure. or this positive and negative and positive together neutral. So you can write it, if you are writing like this in a box, then you don't have to show this positive and negative. This plus and minus becomes, this is the sum total of all the charges. Okay, so that is how. Anyway, shape of ozone is not this, it is bend shape or V shape, but Lewis could not give the shape of this molecules. Okay, thank you.